In this video, we're going to do some more exam-style questions on exponentials and logarithms. In the first question, part A asks us to sketch on the same diagram the curves y equals 2 to the x plus 1 and y equals 1/2 to the x, showing the coordinates of any points where each curve meets the coordinate axis. Okay, let's start with 2 to the x plus 1. We've already seen y is equal to 2 to the x. That's an exponential curve. It will go through the point 0, 1, and the x-axis will be the asymptote. So let's draw a quick sketch of that. We'll come up, we'll come through, and then the curve will grow very quickly from this point on. We have the point here 0, 1, and we've got the x-axis as the asymptote. This is just now a vertical translation of 1 unit. So we pick the curve up and move it up by 1 unit. We're not asked to show the asymptote, but I'm going to do it for completeness, and that will be the line y is equal to 1. So we've got y is equal to 1, and then we've got this point right here, and that will be 0, 2. So y is equal to 2 to the x plus 1. If we now consider 1/2 to the x, we could write this as 2 to the minus 1 raised to the power of x, which would give us 2 to the minus x. Often seeing this as a graph transformation of 2 to the x makes this easier. This is of the form f of minus x, so we're simply now taking 2 to the x and reflecting it in the y-axis. So that will look something like so. So we'll come through this point here, and that will be 0, 1, and then as x gets very large, this will now tend to 0. So we have now 0, 1, and we have y is equal to 1/2 to the power of x. So all we needed to do for that part is the two sketches. It now says given that the curves y equals 2 to the x plus 1 and y equals 1/2 to the x intersect at the point A, in part B we need to show that the x coordinate of A is a solution of the equation 2 to the 2x plus 2 to the x minus 1 is equal to 0. This is this point right here, and that's now the point A. So if y is equal to 2 to the x plus 1 and y is equal to 1/2 to the x, they will be equal. So we can say that 2 to the x plus 1 will be equal to 2 now, and I'm going to write this as 1 over 2 to the x. I'm going to tell the examiner that I'm going to multiply both sides by 2 to the x. If I do that, I'm going to get 2 to the x, which we're going to square. So 2 to the x times 2 to the x is 2 to the x squared, plus 2 to the x is equal to 1. Using the rules of indices, we know a to the power of m raised to the power of n is a to the power of mn. So all I'm going to do here is write now that this is 2 to the 2x plus 2 to the x, and I'm going to subtract 1 from both sides, and that's equal to 0. So that is the equation that we were asked to show. In part C it says, hence show that the y coordinate of A is 1/2 the quantity root 5 plus 1. So what we need to do is go ahead and solve this quadratic, which is a quadratic in the 2 or in 2 to the x. You could go ahead and just go straight at it. Alternatively, you could use a substitution. Let p be equal to 2 to the x. So what we'd have here now is p squared plus p is equal to 1. So we can say p squared plus p minus 1 is equal to 0. That's not going to factor, so we can either use a quadratic equation or complete the square. I'm going to complete the square, p plus 1/2, all squared, then we'll have minus 1/4 minus 1 is equal to 0. So p plus 1/2, all squared, will be equal to 5 over 4. I'm now going to square root both sides. P plus 1/2 will be equal to plus or minus the square root of 5 over the square root of 4, which is 2. So p will be equal to minus 1 plus or minus the square root of 5 over 2. So at this stage we can now take our substitution back and say, therefore 2 to the x will be equal now to minus 1 plus or minus the square root of 5 over 2. Now 2 to the x can never be negative. So if we got minus 1 minus root 5 over 2, that is not going to be valid. So we can say 2 to the x cannot be equal to minus 1 minus root 5 over 2. Therefore, at this stage, we can say that 2 to the x will be equal to minus 1 plus root 5. Just consider root 5 is going to be somewhere over 2, and then we have that now as 2 to the x. So what we're doing is solving this quadratic for 2 to the x. So it's a solution to this equation right here. So we can write 2 to the x is equal to minus 1 plus root 5 over 2. And of course, if you wanted to find now the x coordinate, you could simply now solve for x. This is just a solution to the equation. It now says in part C, hence show that the y coordinate of A is 1/2 the quantity root 5 plus 1. So if we just look at this here, we've got y is equal to 2 to the x plus 1. We already have an expression now, or a numerical value for 2 to the x. So y is going to be equal to 2 to the x plus 1. Therefore, we can say that y will be equal to, and I'm just going to split this up, we're going to have now minus 1/2 plus root 5 over 2 plus 1. So that gives us y is going to be equal to minus 1/2 plus 1 is positive 1/2, and then we're going to have now root 5 over 2. So we could write this as y is equal to 1/2 the quantity root 5 plus 1 as required. So all we've done is got our expression for 2 to the x and subbed it in to show that value. So that's a typical exam style question on exponentials and logarithms. Okay, let's do another one. In part A it says given that p is equal to log to the base 2 of q, find expressions in terms of p for 1 log to the base 2 of the root of q and 2 log to the base 2 of 8q. Okay, so let's just rewrite that first one. So what we have then is log to the base 2 of q to the power of 1/2. Using the power law, we can bring this down, or power rule, we get 1/2 log to the base 2 of q. We know log to the base 2 of q is p, so we have 1/2 p. And that now is an expression in terms of p. Let's look at this one. I'm going to write this now as log to the base 2 of 8 multiplied by q. So what we have here is a product. So we can write this now as log to the base 2 of 8 plus log to the base 2 of q. So all I've done now is split this up using the addition rule. Log to the base 2 of 8. What power is 2 raised by to get 8? The answer is 3. And then we have log to the base 2 of q. So we got 3 plus p. So there now are our expressions in terms of p for these two values. We're now asked to solve the equation in part B. Log to the base 2 of 8q minus log to the base 2 of the root of q is equal to log to the base 3 of 9. This is a numeric value. 3 now raised to the second power is 9. So all we need to do is go ahead and write this. So what we want to do then is solve this equation. We can use this information. So what I'm going to have here is the first part. Log to the base 2 of 8q. We can write this as 3 plus p minus log to the base 2 of the root of q, which is going to be minus 1/2 p, and that will be equal now to 2. 3 to the second power is 2. So what we have here is the following. We're going to subtract 3 from both sides, and then now just tidy this up. So we have 1/2 p will be equal to minus 1. So we can say that p is going to be equal to minus 2. Now, all we need to do at this stage is solve this equation. We're not solving here for p, we're solving for q. So let's now go to the start and just write this in. Therefore, what we can say is minus 2 is equal to log to the base 2 of q. So rewriting now the exponential equivalent, 2 to the minus 2 is equal to q. So 2 to the minus 2 is equal to q. So that's going to give us 1 over 4 is equal to q. So we've solved that equation. And of course, you can go ahead and check that that holds true. So if you want to sub in q is equal to 1/4 and check that it satisfies that equation, you should see that it works. So that's another typical exam style question looking at logarithms.